Microwave sources have two types. First is microwave tubes. First is linear beam tubes, which is O-type. The flow of electron is influenced by the E field. As examples, reflex klystron, and TWT. Second is crosses field tube, M-type. The flow of electron is influenced by the H field. As example, cyclotron frequency magnetron, split anode or negative resistant magnetron, and traveling wave magnetron. Microwave sources of vacuum tube type. Klystrons and traveling wave tubes are examples of linear beam tubes. These have a focused electron beam, as in a CRT. Magnetron is one of a number of cross-field tubes. Magnetic and electric fields are at right angles. Reflex klystron, used as an oscillator. Only one cavity to bunch and collect or catch the electrons. The frequency is determined by the size and shape of the cavity. Electron transit time is controlled by the repeller voltage. When voltage is applied to the cathode, the filament will hit the cathode, which causes the electrons produced. These electrons are focused into a beam of electrons by the anode and will be accelerated forward at the same speed by grid accelerator. Oscillating resonant cavity will produce electric field in a narrow cavity gap. Due to the difference in speed of that electrons and the direction of E field that contrasts with the movement of electrons, causes the electrons are reflected back into the cavity gap by the reflector plate or repeller.
Hi, my name is Muhammad Nakudin bin Muhammad Jamri and my matrix number is 08DP21F1101. Klystron oscillator. A klystron is a vacuum tube that can be used either as a generator or as an amplifier of power at microwave frequencies. Two-cavity klystron amplifier works on the principle of velocity and current modulation. A high-velocity electron beam is formed and sent down to a collector electron. The high-velocity electron beam generated by cathode arrives at the first cavity with uniform velocity. The electron beam passes gap A in the bunch cavity to which RF signal to be amplified is applied and is then lowered to drift freely until it reaches gap B in the catchy cavity. The separation between buncher grid and catchy grid is called drift space. Traveling wave tube (TWT) uses a helix as a slow wave structure. Microwave input at anode, IP of helix. Microwave output near the collector. Energy is transferred from electron beam to microwave. Electron form when cathode heated and release electron. Anode pull the electron and focusing plate concentrate the electron. RF input at RF to electron. Magnet pull this wave and attenuator release the wave in helical structure forming a oscillation. Microwave occur going to RF output and electron go to collector. Next is magnetron, used to generate high microwave power as an oscillator. RM type or cross field tubes in which the DC magnetic field and the DC electric are perpendicular to each other. This is the schematic diagram for magnetron. It consists of two elements, that is the cathode and anode, thus known as diode. The anode is made of cylindrical copper block in which the resonant cavity is connected in series to the cathode interaction zone. Heater is placed axially to the main cathode. Its operation is based on the principal cross field in which the electron will interact with both E field and H field at 900. H field provided by the permanent magnet is placed outside the magnet electron in which the line is force is parallel to the major axis of the cathode.